Hello children, today we start with the new topic, that is analytical chemistry, and we will see the use of sodium hydroxide and ammonium hydroxide in this chapter. Now first thing, what is analytical chemistry? Analytical chemistry is a branch of chemistry that deals with the methods of analysis of chemical substances. So chemistry is broadly divided into 4 branches: physical chemistry, organic chemistry, inorganic chemistry, and analytical chemistry. So this one chapter is from analytical chemistry. We have come across various salts that have different colors. So why do salts have different colors, and what happens if the salt are added to water and their solutions are prepared? We notice that their solution also have distinct colors. Salts of copper, iron are colored, and hence their solutions are of distinct color. So whenever we see copper salts, iron salts, they have different colors, and hence they can impart different colors to their solutions. We also come across a lot of white salt or colorless salts. White salt or colorless salts will give us colorless solutions. Salts of calcium, zinc, and lead are colorless, whereas their solutions are also colorless. So the salts are white or colorless, but their solutions will be transparent or colorless. Now, what is the reason for different colors of the salt and their solution? Why do some salts have colors? And hence they can give the color to their solutions. The color of the salt and its solution is due to its cation. So the presence of the cation in the salt determines whether it will be a colored salt or whether it will be a colorless salt or a white salt. Let's see some examples here. A solution of copper sulfate is blue due to the presence of copper ions. The cupric ions or Cu2 plus ions impart a blue color to the copper sulfate salt, and hence blue color to its solution as well. A solution of ferrous sulfate is light green due to the presence of the ferrous ions present in it. A solution of the ferric chloride is yellow in color due to the presence of the ferric ion. Ferric ions give yellow color to the ferric solution, ferric chloride solution. Action of sodium hydroxide on the salts. Let's see the action of sodium hydroxide on different salts. This is the next topic of the chapter. So very often you will get questions based on which salt reacts with sodium hydroxide to give what color precipitate, and is that precipitate soluble or insoluble in excess of NaOH. So what we need to see over here, first the calcium salt. If we take a calcium nitrate solution and react it or add it to NaOH, we get a calcium hydroxide which is white in color. We need to note that this calcium hydroxide is sparingly soluble in excess of NaOH. So once you get a white precipitate, if we add excess, a few more drops of NaOH, some more amount of NaOH, the precipitate will dissolve, but to a very, very small extent. That's why we say it is sparingly soluble. If we see the example, the next one, that is ferrous salts. When ferrous salts are treated with NaOH, it gives us a ferrous hydroxide. Ferrous hydroxide is dirty green in color. So we get a dirty green colored precipitate, indicating that is ferrous hydroxide. And this ferrous hydroxide, if we add excess of NaOH to this solution, we note that it is not soluble. It does not dissolve. The precipitate will remain as it is seen in the test tube. Now what happens when ferric chloride or a ferric salt is treated with NaOH. When a ferric salt is treated with NaOH, we get a ferric hydroxide. Ferric hydroxide is reddish brown in color. So we get a reddish brown precipitate. This precipitate also is insoluble in excess of NaOH. So both the salts, ferrous and ferric, their precipitates are insoluble in excess of NaOH. Now let's see the example where copper is made to react with sodium hydroxide. So when a copper salt like copper sulfate is made to react with NaOH, it gives us a copper hydroxide. The copper hydroxide is blue in color, pale blue. If excess of NaOH is added to this, it is insoluble. So it does not dissolve. The precipitate will remain as it is. So copper salts give us a pale blue precipitate. Now let us see the action of sodium hydroxide on a zinc salt. So if a zinc salt like zinc sulfate is treated with NaOH, we get a gelatinous white precipitate. This gelatinous white precipitate is zinc hydroxide. It is gelatinous jelly-like in nature, it is white in color. But when we add excess of NaOH to it, we are going to get, this precipitate is going to dissolve. So we are going to get a colorless solution. Why? Because when this reaction takes place, that is zinc hydroxide reacts with NaOH, it forms a complex salt of sodium zincate, which is soluble in water, and hence the precipitate dissolves. So zinc salts give us a gelatinous white precipitate, and in excess of NaOH, it will dissolve. So it is soluble in excess of NaOH. Now let us see lead salts. Lead salts, like lead nitrate, when made to react with NaOH, give us a white precipitate, a chalky white precipitate of lead hydroxide. So a chalky white precipitate of lead hydroxide is formed. And what is that? This precipitate is soluble in excess of NaOH. Now why is it soluble in excess of NaOH? When lead hydroxide is treated with NaOH, it gives us sodium plumbite, which is soluble in water, and hence the chalky white precipitate disappears to give you a solution. So the precipitate dissolves. Lead salts give us white precipitate, which is further soluble in excess of NaOH. Now let's see the example of action of sodium hydroxide on the solution of salt. So if ammonium salt is made to react with sodium hydroxide, if ammonium salt, this time we are taking an ammonium salt like ammonium chloride or ammonium sulfate, if that's made to react with an alkali like NaOH, it gives us the corresponding salt, as well as it gives us water and ammonia gas is released. So in this case we don't see precipitates, ammonia gas is released. Okay, so till now we have seen different examples of action of sodium hydroxide on various salts. Now let us see the action of ammonium hydroxide on salts, on various salts. So first thing, we'll start with the calcium salt. When we start with the calcium salt, we see that no precipitate occurs even in excess of NaOH. So if you take a calcium salt and you add ammonium hydroxide to it, it does not give us any precipitate even if we add excess of NH4OH, ammonium hydroxide. Now why does this happen? This is because the concentration of hydroxide ions from the ionization of ammonium hydroxide is so low that it cannot precipitate the hydroxide of calcium. The OH concentration levels are very low here, so that's the reason it cannot give us any precipitate. Now let us see the action of ammonium hydroxide on solutions of salt. This time iron salt. So when a ferrous salt, like a ferrous sulfate, is made to react with ammonium hydroxide, we get a dirty green precipitate again, because the product form here is ferrous hydroxide, which is dirty green in color. And this again is insoluble in excess of ammonium hydroxide. So if we add excess of ammonium hydroxide, it is not going to dissolve. The precipitate will stay as it is. And if you take a ferric salt, like a ferric chloride or a ferric sulfate, in this case we get a reddish brown precipitate of ferric hydroxide. This precipitate is also insoluble in water. So we see that we are getting a dirty green or a reddish brown precipitate. Dirty green is for ferrous and reddish brown is for ferric. And both these precipitates are insoluble in excess of ammonium hydroxide. Now let's see the action of ammonium hydroxide on a copper salt. What happens when a copper salt is reacted with ammonium hydroxide? So when a copper salt is reacted with ammonium hydroxide, we get a pale blue precipitate of copper hydroxide. So a pale blue precipitate is formed. Now this pale blue precipitate will dissolve if excess of ammonium hydroxide is added. It forms a deep blue color. It gives a deep blue solution. Now why does it give that color? Because copper hydroxide, when it is reacting with excess of NH4OH and also the salt that is present in the solution, that is ammonium sulfate, altogether it gives us a complex salt of tetraamine copper 2 sulfate. This is a complex salt of tetraamine copper 2 sulfate which is soluble in water, and hence it also gives a inky blue or a deep blue color to the solution. So copper salts give a pale blue precipitate in the first case with ammonium hydroxide, and with excess of hydroxide it gives a deep blue or a inky blue precipitate. Inky blue color to the solution, sorry. Okay, now let us see zinc salts. When zinc salts are made to react with ammonium hydroxide, we get a white gelatinous precipitate of zinc hydroxide. This white precipitate is soluble in excess of ammonium hydroxide. So if excess of ammonium hydroxide is added, this white precipitate will dissolve. So zinc gives us a gelatinous white precipitate which is soluble in excess of ammonium hydroxide. Now let's see for the lead salt. A lead salt like lead nitrate, when made to react with ammonium hydroxide, gives us lead hydroxide, which is a white precipitate. It's a chalky white precipitate of lead hydroxide. This precipitate is insoluble in excess of ammonium hydroxide. So if excess of ammonium hydroxide is taken, this precipitate will not dissolve. Now let us see a comparison of action of sodium hydroxide on salts and action of ammonium hydroxide on salts. So first we see various salts, how they impart different colors to their solutions and different precipitates are formed. So first we see here for the calcium salt. So calcium salts, when reacted with sodium hydroxide, give a white color which is sparingly soluble in excess of ammonium hydroxide. Now let's see the calcium salt's reaction with ammonium hydroxide. A calcium salt reacts with ammonium hydroxide but does not give any precipitate. It does not give us any precipitate. Let's see the example with the precipitates present. Okay, so first we see that calcium salt, when reacts with sodium hydroxide, gives us a white precipitate. But calcium salt with ammonium hydroxide do not give any precipitate. Ferrous salts with sodium hydroxide give a dirty green precipitate which is insoluble in excess of sodium hydroxide. Whereas ferrous salts with ammonium hydroxide, here also they give a dirty green precipitate which is insoluble in excess of ammonium hydroxide. Similarly, it is the same with ferric ions. So ferric salts produce a reddish brown precipitate which is insoluble in excess of both sodium hydroxide as well as ammonium hydroxide. Copper salts give us a pale blue color precipitate which is insoluble in sodium hydroxide but which is soluble in ammonium hydroxide, whereas in ammonium hydroxide it gives a inky blue solution color. And zinc salts give gelatinous white precipitate. In both the cases they are soluble, whether it is with ammonium hydroxide or with sodium hydroxide. In excess of sodium hydroxide or ammonium hydroxide, a zinc salt is a zinc precipitate, the white gelatinous precipitate, it is soluble. Lastly, we come to the lead salts. Lead salts also give us white chalky precipitate in both the cases, and these precipitates are soluble in excess of sodium hydroxide and ammonium hydroxide respectively. So we see the difference in the copper salt and there is a difference in the calcium salt. So in calcium salt, when it is reacted with ammonium chloride, there is no precipitate, and in copper salts, the difference is both give pale blue precipitates, but with sodium hydroxide it is insoluble, whereas with ammonium hydroxide it is soluble. So once again you can just see this chart at one glance. It will help you to have all these reactions at one time.